who come from a general background, sorry, the screen is doing something to me, need to learn the specific context of the company they're working in. So there were some on the job training needs, but there wasn't a technical skill shortage. And so we got quotes like these from the interviews. The effects are in the camera. You can immediately see that you're cutting out a huge part of the production pipeline, all the costs associated. One designer said, who was looking at user interfaces, a button that we wanted to put in would have cost close to £30,000 in development costs, but now it's zero because we can iterate things before putting it into the car. This was the design of a car, what they called dashboard. So in that case, why isn't everybody adopting this technology? And don't worry, I'm not going to talk about the equation. And the answer is partly that there are some direct technical costs. You've got to buy the GPUs. For some industries, you've got to buy the very expensive screens. There's some licensing costs. The training, there was some on-the-job training costs in the pioneers, as I said. For the incumbent companies, the training costs could be quite substantial because they had to upskill a lot of their people. And there was this contrast between the two types of companies in terms of how agile they were, which was the early adopters, versus the large legacy companies, which carefully pilot things and take time to think about it because they're so risk averse. And so contrasting quotes here, Epic Games are great, whole bunch of free tools. You could join the academy, it didn't cost anything. And then in a big financial services company, chief information officer saying, you've got to check and balance as you go. There are lots of small steps. So already there's this insight into the two different types of company, much easier to adopt the technology if you are one of those pioneers and you're in a sector that is quite tech friendly to start with. But then the big bucket was the organizational costs. A lot of companies, a lot of incumbent companies understand productivity as cost savings or easy to quantify operational efficiency savings. And so it was harder for them to think about how do you trade cost savings off against long-term innovation and the long-term benefits that you might get from adopting a technology. So the cost-benefit analysis that they would do would be very short-term. They in the business of incremental change, not radical change. They were thinking about the technology as how to do incremental changes better and make those cost savings and efficiency savings. Often the boards had relatively few people who've got the technical understanding, but importantly, the need for change management and to bring employees along with it made it a much slower process in larger incumbent companies. And the decision-making environment, therefore, is much more complex, much more costly, and there's great risk aversion. This would extend to operational disruptions. If you're bringing in a technology that will change your workflow and processes, you've not only got to get people to change the jobs that they do, you might be running two systems in parallel, and there's a cost associated with that. There are cultural issues. People don't like change. There are coordination issues. So it's just a much more complex business to bring this technology into an existing company. And I think this is very much underestimated in the debates, the policy debates about diffusion, because we're talking about an information technology. It enables people to predict things better. And if you're predicting things better and getting additional information, people have to be able to use that information to get any productivity benefit from it. If you don't change the decision structures so people can use the information, you don't get the gains. And then on top of that, there are bad experiences of projects that have gone wrong and been very costly, and also the sunk costs sometimes in having an existing technology that hasn't depreciated fully and you don't want to replace it yet. And so some of the quotes from the big organizations, it's not unusual to have a call with 40, 50 or 60 people on it, which sounds like the Zoom from hell, doesn't it? Projects vast cost overruns and time overruns, a common experience. And then convincing someone to use a tool that they believe will replace their job over the long term. So the stakeholder management issues are really intense. And then finally, I think some external pressures, competition in the market can really affect how urgent companies feel it is to adopt technology. And so in financial services examples where there are fintech startups and some more competitive pressure than there has been previously. And then client demands as well. So one of the rare complaints we had about the affordances of the technology from the pioneers was that clients think it's magic and there's no cost involved with it. And actually, there is also some cost involved in it as well. I'm going to skip over the equations. Non-economists don't like that kind of stuff. So we've organised the costs into these two buckets. The technology costs, which most of the literature has focused on in the recent wave, and that's pretty straightforward. Fixed cost, upfront investment, variable cost, running, compute, and so on. And then the organisational costs. And so the next area that we will go to in this work is thinking about the management demands, the management quality needs, and how much are those different organisational costs, and can we address those? And so we think we can reduce adoption costs, which may be training, maybe different kinds of platforms to spread fixed costs, which would be helpful for SMEs. Lowering risk. There are some interesting historical examples here of managers being taken to visit companies in the US in the post-war era, in Japan in the 1990s, to actually see how companies did things and bring that knowledge back and share it through their own supply chains. And then some sector-specific issues, including clarifying regulation, because for a big company, uncertainty about what the regulations say you can and can't do can be a big part of that cost. So the conclusion here, AI is not a matter of technical feasibility only, it's about organisational readiness and those systematic costs. And so we'll carry on working on this. I want to add one off-script final comment, which is about another project that I'm involved in, looking at AI models, generative AI models, and making the case for an Airbus for AI. This is an example of a pan-European project that succeeded incredibly well in the market against Boeing. And we make the argument that you could think about pooling resources from 3 or 4 European research labs or institutes to develop something similar that would have the scope to compete against the American models and the Chinese models that we were hearing about earlier. I had thought that kind of thing might come up in the previous session, and it didn't, so I will put it on the table for now. But that's it from me. Thank you.
Thank you very much. Indeed, I'm going to talk about today, I titled the presentation, Fostering an Inclusive Digital Transformation as AI Spreads Among Firms, because this is the title of a recent policy note where we summarize some of the findings that I'm going to discuss today. The usual disclaimer is on the slides. These are my personal views only. And if we go to the next slide, we'll see a little bit the outline of this talk. And what I'm going to talk about today is to try and provide some evidence based on a number of studies that leverage different sources of microdata and look at questions related to AI diffusion, and in particular at the characteristics of firms that adopt artificial intelligence, and the role of different enablers, including notably human and technological capital, as well as at the links between using AI and productivity at the firm level, and then try and summarizing, drawing policy implications based on this empirical analysis. In the next slide, we start from heterogeneity across sectors. And what we've seen in a recent study that is called a sectoral taxonomy of AI intensity is that artificial intelligence does not affect all sectors of activity equally. And in particular, here we have looked at different ways to measure AI that have also been used in the literature, but we highlight that they actually captures different facets in the extent to which AI affects economic sectors. And in particular, we focus on AI talent, so the demand for AI-related skills, AI innovation, so the extent to which there are new AI applications developed, the AI exposure, which is a measure of the potential related to artificial intelligence, measured through the extent to which AI affects skills and occupations, as well as the actual use by firms of artificial intelligence. And on the right, you see a summary figure that looks at the different dimensions. And what you see is that sectors that score high across the different dimensions, so that have high AI intensity, are also shaping the technologies. These are typically sector in ICT, the ICT services sector, as one might expect, as well as some of the professional services. In fact, focusing on the last column, AI use is highest in the professional services as well as in the ICT sector, suggesting that probably for the time being, the potential of AI as a general purpose technologies is yet to fully materialize. And zooming in on the AI use in the next slide, we leverage an exercise that we have carried out across countries, developing statistical code and sending it over to statistical offices across more than 10 OECD countries, carrying out harmonized analysis. So using always the same code, which is applied to highly representative firm-level surveys of technology adoption. And from this data, as well as from other commercial and administrative microdata, upon which we'll base other studies that I will discuss today, we highlight some of the characteristics of AI adopters. And one of the key characteristics that emerges across the board is the fact that there are some scale advantages, so that AI is more widely used among the largest firms. And you see this in the figure, where the larger circle on the top right should suggest and highlights that in all the countries for which we have carried out analysis, the largest firms, so those that have more than 250 employees, exhibit the highest shares of AI use. And this is not only true descriptively, but also when we carry out econometric analysis, when we can control for the sectoral composition of economies. This means that even within detailed sectors, larger firms tend to use artificial intelligence more. And in the next slide, we instead look at the age of the firms, and we see that, at least to some extent, younger firms, including startups, have a strong tendency to use AI. And you see that if you look at the figure at the firms that are on the right with 11 or more years old, they tend to have lower share of AI use across many countries for which we have carried out analysis. In the next slide, we leverage different sources of commercial and administrative microdata. We merge patent data proxying for AI innovation, job posting data looking at the demand for AI-related skills, as well as data from online website looking at the extent to which firms may have AI at the core of the business. And this suggests, focusing on the UK, that there is probably not such a thing as a typical AI adopter. In fact, when we look at different groups of AI adopters, we see that while AI innovators and firms with AI at the core of the business tend to be concentrated in the ICT sectors, companies hiring AI talent appear to be more widespread across sectors. There are relevant complementarities and interdependencies in digital technology diffusion, and we see this in the next slide, where, leveraging commercial microdata, we are able, looking at the differences in conditional probabilities of adopting different digital technologies, to draw a directional network of looking at the diffusion and adoption of different digital technologies. And we see that there are some technologies that are more at the bottom, that are more foundational, and then they are relevant to build upon the next steps of the digital transformation, suggesting that this is a path-dependent process that is unlikely to happen abruptly, but rather builds upon pre-existing expertise, infrastructure, and knowledge base. And we see these interdependencies also in particular in the case of AI, where we are able to look at the links between different types of AI technologies. And this is focusing on France. And this is a figure that suggests, in fact, AI technologies exhibit significant interdependencies among themselves, but also tend to support different AI technologies, tend to support different business functions. And you see this in the figure looking at the red square. We suggest that technologies such as machine learning and data-driven decision-making and automation seem to be the types of AI technologies that tend to support most of the business functions that we can see in the French data. In the next slide, we look at the relevance of enablers, of complementary assets that are linked to the use of AI among firms, and with econometric analysis across more than 10 OECD countries, the results suggest that human and technological capital, including digital infrastructure, digital capabilities, as human capital and internationalizations, are factors that are relevantly and positively associated with the use of artificial intelligence across countries. And in particular, human capital appears to play a particularly important role, and we see this also in the next slide, where we see that the relevant human capital does not only include ICT skills and technical expertise, which are consistently associated with higher probability of adoption across countries, but also socio-emotional and foundational skills. In fact, when we look at leading firms in the US that demand for most AI talents, we see that these firms have a higher demand for AI professionals that combine technical skills with innovation, problem solving, and leadership skills. And we do further analysis that corroborates these results for AI developers in France. In the next slide, I'm going to talk a little bit about our results when we look at when we link the use of artificial intelligence and productivity. And what we see across most of the countries is that AI users tend to be more productive than other firms, but that these productivity premia do not seem to reflect the use of artificial intelligence alone. In fact, complementary assets, in particular human and technological capital, appear to play a critical role for the productivity premia, because once we account for those in regression analysis, the productivity premia of AI adopters tend to significantly reduce or disappear, suggesting that probably these advantages may be linked to the selection of more digital and competitive firms into the use of artificial intelligence. We see, and this focuses on predictive AI systems, so before the boom in generative AI. We see, however, initial evidence that of more direct effects of developing artificial intelligence or productivity, and we see this in the next slide, focusing on France, where these productivity advantages, when it comes to developers, appear to remain even after taking into account all the role of these complementary assets, the role of human and technological capital, and even when taking into account more directly identification challenges related to endogeneity, and we're looking at the different productivity measures. Recently, we have also reviewed the literature about the links between generative AI and productivity. And in the next slide, you'll see key findings from a literature review that is coming up next month, which highlights that when it comes to generative AI, it seems to exhibit significant potential to qualify as a new general purpose technologies with relevant gains across for productivity, innovation, and entrepreneurship among the experiments that we have reviewed in the literature review. But the impact of generative AI appear highly dependent on how it is utilized, for which purpose, by whom, on the level of expertise of the users, and on the trust in the technology, especially when it comes to navigate more complex tasks where the input need to be contextualized by deeper knowledge, suggesting that probably a critical approach where human AI collaborations that consider both context and user expertise may be the relevant one, with AI serving as a complement rather than a substitute for human capabilities. And I'm about out of time, but in the last slide, I just summarize some of the policy implications that can be drawn from this work, highlighting the relevance of driving AI innovation and inclusive AI ecosystems, supporting firms' digitalization and enabling infrastructure, as well as developing human capital for AI adoption and use, notably including the critical thinking that may help understand how to best, when to use AI and to best leverage its potential, as well as to cooperate for trustworthy AI governance. Thank you very much.
Great. So my name is Natasha, as Jess just said, and I'm going to give some perspectives from the interface of AI and engineering. So I don't think I could tell you anything that I could call a trend in AI adoption or diffusion, but what I can do is give some specific examples of what we are seeing in terms of AI innovation and what opportunity that might create for AI adoption, but also to talk about what we think is important in terms of how we shape AI innovation and adoption so that it really is genuinely beneficial and meet the needs both of the adopters, but the people that those adopters are trying to serve. So because I'm giving you something that is very much a perspective from a specific organisation, the Royal Academy of Engineering, I'll just take a moment to explain who we are and what we do. So the Royal Academy of Engineering is the UK's National Academy of Engineering. As a national academy, we are a fellowship. So we recognise brilliance in engineering in the UK and internationally. We have phenomenal fellows, some of whom have created the very chips that are powering AI and all these systems that we're talking about, some of whom are doing other things like creating roller coasters and Heathrow Terminal 5, but people who are creating the real engineering stuff in the world. But we also, as a National Academy, fund research. We have a number of research funding programs, including a 10-year chair in emerging technology, to enable engineering researchers to take innovations from research to reality. And that includes areas such as neural interfaces, health, energy systems, and so on. And we're really keen to ensure that all of that brilliant engineering research reaches kind of the market. So we have an enterprise hub, which is a cluster of accelerators supporting spin-outs, startups and scale-ups to get that research and innovation out to market. And a lot of what I'll talk about today will basically look at some of that work that's going on in those enterprise hubs. But I wanted to talk about this interface between AI and engineering for three reasons. One is I think there is a huge amount of benefit for AI adoption in the engineering space, which isn't already happening, and possibly for some of the reasons that were covered in the last two talks. Secondly, there's a huge amount of benefit here. There's a real kind of opportunity. And thirdly, because I think an engineering approach to adoption and diffusion can help really unlock that benefit in a productive way. So here we go. So I'm going to give you some examples of what we are seeing in terms of innovation and adoption. So our enterprise hub takes individuals who are leading companies, who are spinning out of universities, who are growing as organizations, and gives them insight and knowledge and access to investment to grow their products. And I just wanted to pick out a few examples of companies that we're seeing in our hubs that might kind of suggest some interesting routes for innovation and adoption. And as I say, these are not trends, but they're interesting examples. And I think they have been shown, partly from what we've been hearing today, to be particularly interesting. So we are seeing more and more examples of AI applications at the kind of area of manufacturing, heavy engineering, traditional engineering. We no doubt see many companies who are working on AI and software. We see a strong area in health and resilience and health and social care, but this is a really interesting area to me. So I'm going to pick out a few examples. Firstly, one that's not on there, Donna AI. That's a company which are using AI to help improve manufacturing processes. So taking things like 3D manufacturing, looking for faults, detecting faults early. That has a big impact in terms of saving materials, having greater sustainability, greater productivity. So that kind of traditional heavy engineering to the edge of kind of a more kind of complex engineering, manufacturing, using AI to make that work better. You've also got matter there. So that's an area where they're using AI to think about how you improve processes across the whole factory. So automation and learning across processes to create greater efficiencies, to create better ways of working, greater yield, maximizing that kind of ability to turn products around quickly that we talked about earlier, and also finding new ways of doing things. So innovation in that kind of factory setting. And even more kind of complex and potentially messy and very much at the heart of traditional engineering, we've got NPlan, which is about AI for project controls and delivery. And this is about learning from lots of complex construction type projects, that kind of large scale engineering project that traditionally see costs overrun, see complexities, and looking at how to do that better and how to avoid those challenges. So all of those are examples of AI innovation that is happening at the more complex and, if you like, messy end of engineering, which, if I took the messages from the last few talks rightly, is not really at the very forefront of AI adoption, but where there's a great opportunity for making progress. Another couple of examples I've got here, one is ArcAI. That's looking at AI to look at land use. So, for example, using images to be able to see historical land use, looking at archaeological patterns so that we can develop land sustainably, safely, and conserve nature better. And you've got, for example, companies like Monolith who are looking at accelerating the kind of R&D process so that it can happen more quickly. And I've picked that out there because that's an example where they're working on a challenge that we all know is necessary. So battery development, so something that's absolutely essential in engineering development so that engineering can achieve greater benefit in terms of sustainability. So what I wanted to just pick out from these examples, again, they're just kind of examples, they're case studies, they're not strong trends, is that we can foster AI innovation in areas where adoption would be most beneficial. And I think it's really interesting to think in this context about what are the research and policy drivers to enable this kind of AI innovation and adoption. And this leads me to my second point, which is, what is it to take an engineering approach to AI innovation and adoption? And I wanted to talk about a concept, a philosophy that we're developing at the Academy at the moment around practical AI. And this is particularly close to the heart of our president, Sir John Lazar, who's worked for many years in cloud computing, chair of the Raspberry Pi Foundation, who wants to talk about practical AI, and sometimes he says boring AI, right? So the AI that actually does jobs that we all sort of need to see the benefit of, that makes a difference to people's lives, that is not necessarily, you know, the kind of exciting generative AI, but is doing stuff like fixing potholes, making kind of projects not overrun, delivering benefit more quickly. And what we're trying to do at the Academy is build that approach to practical AI in two ways. One is by having conversations with people across the country about what is actually going to be beneficial for you. So this is a little bit like the kind of model Neil was talking about at the beginning. Our enterprise hub has bases across the UK. So we have been bringing together the entrepreneurs supported by those hubs with their local communities and with local stakeholders to talk about the needs that they see. We've had conversations in Belfast, Glasgow, Liverpool and Swansea, and we'll be talking in London soon. And what's come out of those conversations is the fact that we can see, yes, there are lots of the traditional areas where we talk about AI around, you know, better diagnosis of disease, more rapid turnaround results from scans. Those are really important concerns for people. But again, it's these kind of practical everyday experiences of complexities and sort of log jams, for example, in terms of health delivery, in terms of understanding how you can get better access to transport and mobility, and understanding how you can create systems that are just much better for the user interface. And for us, practical AI is about having those local conversations with local communities, but it's also about having conversations with the engineers. And what we need to be tapping into is what are the genuine challenges that engineering companies are seeing? What are the genuine needs that they have? And I think some of those examples from our enterprise hub that I just talked about are all about using the kind of ability to innovate and adopt to unlock some of those problems. And for us, practical AI is very much about having that kind of practical, situated approach to AI innovation adoption, understanding what it means locally, in terms of local needs, especially as you hear about them from local communities, but also local strengths as you would hear about them from local companies and innovators. Now, my last point then is about an extension of that concept of practical AI to what you might call proportionate AI. So we're really concerned at the Royal Academy of Engineering that when we are promoting the use and adoption of AI, we do so sustainably. We are all aware, and I think this came up a little bit earlier, about the fact that the resource appetite of AI is growing, both in terms of energy, water, materials. And we really need to work to ensure that we're building AI that is more sustainable, that can work under constraints so that we can think about more sustainable ways of adopting AI. And we've done some work. This is the first phase of a larger project to find the foundational steps for sustainable AI, those necessary but not sufficient conditions to enable AI to be more environmentally responsible. So we talk about the need to expand environmental reporting mandates to address information asymmetries across the value chain, to understand that we need to set some sustainability requirements for data centers and think about how we collect, transmit, and store and use data, and that we need government investment to really promote these sustainable forms of AI. And to go with the theme of today, that point about addressing information asymmetries across the supply chain, this is all about improving access to data about how AI works, about its environmental footprint, so that those who are using it proportionately and are using it in ways that kind of meet needs. And I think that this is really important for two reasons. First, it's important because it will help us to manage the footprint of AI as we adopt it, but also innovation under constraint can perhaps open up the opportunity to do more diverse ways of doing AI, so we can create better systems that meet the specific needs of particular adopters. We heard a little mention of DeepSeek earlier, and that's a really nice example of how we're not locked into particular very large language models. We can think about different ways of doing things. So I think as we think about innovation and adoption, we need to think about those incentives that enable us to do that sustainably. And then just to wrap up, because that for us is very much about that engineering approach to innovation and adoption. The value chain for AI is complex and interdependent in many ways. And as we create more use of AI, for example, to help create decarbonised energy and create greater efficiency, we're also creating systems that have got an energy appetite too. And we have to think about the complex interdependencies between those as we develop AI, as we innovate, and as we promote adoption. So looking forward to hearing more from my fellow panelists to discuss this further.
How can I put this somewhere I can see? It's lovely to be here. Thank you for inviting me. I'm associated with the Bennett Institute at the University of Sussex, so it's lovely to come over and be around our fellow Bennettees. Is that the right phrase? So it's great to be here. I'm going to talk a little bit about a chunk of work that we've been doing on AI at Sussex, and really kind of respond to the call that I was asked to do to talk about innovation and diffusion. So this is some kind of general thoughts on innovation and diffusion. I'm editor of a big journal that publishes a lot on AI. So I'll draw on a lot of work that's been done there. So some definitions to start with. Invention is the first time we come up with a new idea. Innovation is the first successful commercialization. Okay, so the emphasis there is on commercialization. It is not just creating value, it's also capturing value. And that is a really, really important feature when we're talking about emerging technologies, because there's this key issue about, can you capture enough value to reinvest and push technologies forward? And that's an interesting issue that perhaps we'll talk about. One concept I want to get across is a concept from chemistry, and that is the rate limiting step. Okay, so in chemistry, you can have lots of bits of reaction being fantastic, 1,000-fold improvement. If one bit of your reaction is still slow, the overall performance is still going to be slow. So when we're talking about innovation and diffusion, if there's a bottleneck that isn't being improved on this technology, the productivity increases are going to remain low. So that's a kind of a key thing. Fantastic improvements in one area will not necessarily lead to improvements downstream if there are bottlenecks. So we'll talk a little bit about that. Okay, so that is important because if we look at the history of the emergence of radical and important technologies, we do see a couple of features which the historians will constantly remind us of. First of all, that the process of diffusion and uptake of technology is typically slow. Okay, it can take often decades to do this. We have strip lighting here, 76 years from getting it to work in the lab to have it to be a commercial success. Now, over time, we have seen improvements in that, but we would not expect, if we were economic historians, to see big changes in productivity within years. Okay, we're thinking about decades here. So that's a kind of a key thing. So diffusion and use, I think, is really kind of constrained by the primitive nature of technologies when they are first developed and the long period of time it takes to actually do this learning. I am reminded of Watson at IBM, who predicted that the total market for computers was going to be 5. Okay. He was the head of IBM, and he thought the global market for computers was going to be 5. So if someone as smart as him, who was really, really smart, had difficulty predicting how important IT would be, then we need to be kind of careful a bit. In terms of diffusion, we have a lot of research on diffusion of technology. So Everett Rogers' brilliant book on diffusion kind of highlights that, when we're looking at use, things like complexity, do you have to learn? Are there complementary technologies that you need? Are there problems with learning? And with many AI technologies, the answer to a lot of that is no. Actually, they're relatively simple to use. They're free to use. The costs are often zero. But on the learning side and the organizational learning, there's a bottleneck there. So we would expect with these technologies for there to be very, very rapid uptake of technologies, but the actual big drivers of downstream changes to take it a bit longer. What's interesting, I think, from a research perspective, is that AI technologies can teach you to use AI. So one of the things when you teach prompt engineering is kind of teaching your students to use AI to improve the prompts that they put to AI. And it's very good at that. Surprise, surprise, AI has learned from people who create AI systems. Okay, if we go kind of beyond that kind of initial use of technology, we are seeing that the impact of this is slower, as kind of has been highlighted. Okay, let's talk about some kind of key points now. So innovation, first of all, I think it is important to say to a UK audience, if we're looking at innovation in AI, we've had a failure of UK science policy. The UK is a long way behind here. We should have done much, much better than we have. So there has been a problem there. We've been using some data from DeepMind to look at where the UK is, and it is really rather alarming and worrying. We perform moderately okay if we include DeepMind. If we take DeepMind out of UK data, the UK is performing a level of roughly a Singapore or Switzerland. That is really pretty poor. So claims that we are an AI superpower are not a good fit with the data. And we can see some kind of quite interesting, when we look at that data, some quite interesting differences across countries. So China has been extremely strategic. So looking at the areas that China has moved into, there is a very nice correlation between the area China has moved into and the areas that then grow 5 years later. So it looks like they've been clever. The US has been very, very good across the board, but much more commercial in its innovation processes than China, though I don't think we should read that as market-led. So the firms in the US that have been doing a lot of AI are very closely associated with the US state. The UK has done a rather bland bit of fairly waffly industrial policy, kind of post-1985 fairy stories that if we get the science right, magic will happen. No, it hasn't yet again. We knew that in 1985, and it's still kind of being a problem. Okay. So let's talk about kind of diffusion and use. So we can understand diffusion and use technologies reasonably well. I think we've got some fairly good kind of ways of understanding technology. We start off, we ask, what do customers want? Do customers want price or performance? Customers want price, so therefore they want low price. We're going to have process technology. Process technology comes from suppliers, and they also want performance. Is it a service? Yes, therefore it's also process technology. So a double hit of process technology on the production of AI. Lots and lots and lots of technology from suppliers, because that's the main source of technology for process innovation. Are there any economies of scale? Yes, huge economies of scale. Are there any risks? Yes, massive risks. Therefore, we'd expect to see very significant production engineering capability that would switch to software engineering capability if it is a software-based service, which it is. So we would expect these firms to be taking lots of technology from suppliers. We're talking about this morning the importance of supply chains and chips. Yes, it's a really, really key part of innovation in this sector, and also very significant in-house software engineering, which is what we find. Are there any complementary asset plays? So complementary assets in the management literature is a very specific thing. It is the assets to capture value. So are there assets at play that allow you to capture value? Software innovation at scale has a built-in complementary asset, which is hard to copy software engineering capability. So we'd expect these firms to be able to capture quite a lot of the value of the innovations that they do and grow to be big. So our industrial structure expectations would be a small number of large firms taking a lot of technology from their supply chains and having a sophisticated software capability, which is what we find. Okay, so it's very, very aligned with what we'd expect theory to give us. In terms of the capturing value kind of part of that kind of story, I personally am not clear in the long term whether that's actually been kind of stitched up by these firms. So are they going to be able to capture value in a way that will enable that kind of continuity of the early success they've had? So it's a really interesting service model in terms of innovation, but not particularly radical, as this isn't something that's kind of different from what we would normally expect. Okay, if we go on from the suppliers and talk about customers, we've seen a very, very rapid uptake in the use of this technology as a service. So ChatGPT has between 500 and 1 billion individual users per month. That is a very, very rapid diffusion. But we don't really have great data on how that is being used. So are you using ChatGPT to fundamentally transform your organizational processes, or are you using ChatGPT to take a picture of your kids and put a bunny with it? You know, these are important questions. Luckily, there is some data that's becoming available to academics from that. So Anthropic has been releasing data about firm level and individual level AI use, and it is kind of what we would expect. So the vast majority of people are using AI as basically a substitute for Google, but there is a small number of people in a small number of firms who are doing much more sophisticated things with it. And that is gradually diffusing out through the economy relatively slowly, but it's an important change in the economy. So that data is interesting. In terms of the diffusion of that technology, going back to the Rogers on the diffusion of technology, things that are going to influence it is ease of use. So, the technologies that reduce complexity for users, enable learning for users, and kind of sort out all the complements that are needed are likely to diffuse further. Going back to this point about rate limiting steps, it is that complementary change that is the rate limiting step. So his organizational change is difficult, and it remains difficult. So AI can come in and do fundamentally brilliant things in lots of areas, but the rate limiting step is still there. Okay, so when we look at the organizational changes that are going on, we see a kind of a fairly clear pattern with this diffusion. So first of all, people are using it to improve what they're doing. Secondly, they're using it to replace stuff that they were doing, and that changes jobs. An important part of that is reducing dead ends. So AI is being used to reduce the number of dead ends that they've explored. That is leading to changes in organizations and the reduction of people. So you take people out of the organization because the people you've got are being more effective. And then the next step is the difficult one in an organization, to move from that replacing stuff that you were doing before to doing something new. When people leave organizations, the jobs that are left change, and that human capital bit is really difficult. So there's a gap in the kind of human capital bit there. So the rate limiting step in that innovation bit is really learning about organizational change while you're using AI. Firms find this very, very difficult to do. There isn't good academic data. The randomized control trials that have been done have really serious construct validity issues, and they're probably out of date by the time they're published. So it is hard. It is difficult. We do know in terms of one split, which is there a risk involved? If there is a risk involved in the use of AI, humans are in the loop, and that massively complicates everything. That slows down these organizational changes and the kind of productivity changes. But we are seeing very, very significant use of AI across a number of sectors in the most technically advanced firms within those sectors. And I think that is across sectors. So it was interesting, the data you had showing that there were a number of sectors where there wasn't much going on. We're getting a lot of case study stuff, even from those sectors, saying that there are these firms that are doing interesting things. So it would be interesting to kind of get a sense about where that data is. We are still struggling to see results, though. So you think about a company like GSK. GSK has been throwing money at AI throughout every single bit of drug discovery for decades. They've basically bet the farm on it. Are we yet seeing evidence of big improvements in drug discovery? Senior management would say yes. Shareholders would probably say no. It's uncertain. It's time will tell. Okay, but it is, these are very, very clever people. They're getting incremental improvements that are gradually changing, and that is something that's important. Okay, so the key issue to kind of finish up on for me is the kind of the business models on this. In terms of things like compute and access to chips, I'm a bit skeptical that's an issue. If you want access to chips and you want access to compute, then stop making illegal weapons, stop being involved in human rights abuses, and surprise, surprise, export controls won't apply to you. So I think we'd be interesting to go back to that previous thing where we had the picture of all the different countries and the global north and south and see if there's any overlap between the nations that are after this technology and nations which are a nuclear proliferation risk. I would suggest that there probably is quite a lot of overlap there if you look at that slide. Okay, value capture, I think, remains a very, very interesting issue. It is the other half of innovation. Innovation is creating value and capturing value. The value capture bit is the bit that's super interesting here. A lot of firms do not like using AI as a service because they don't want to send data off, well, often aren't allowed to send data off to other countries, but they don't want to give data or anything that's commercially kind of sensible. They're not going to do it. Law firms really, really struggle with this idea of client-sensitive information being given out and try very, very hard to clamp down on it. That is an issue. So you're seeing some interesting stuff going on in-house, and that raises some interesting questions about a concept that Google software engineers have come up, which is a brilliant concept called technological debt. Okay, so this is you start making a piece of software and you solve a problem, but it's like taking kind of money out the bank. Eventually, you're going to realize you've messed up really badly in your architecture and have to rebuild it all over again. So which firms are accumulating this hidden technological debt and which sectors is going to be an interesting question. And I think people like James Besson are doing some really interesting work on how that's affecting competition across a range of markets. Disruption to technology, I think, is really interesting. DeepSeek is a really, really interesting disruptive technology. So the whole issue about this kind of continual kind of growth in terms of scale, DeepSeek is kind of very interesting there. And then capturing value, there is a very, very interesting thing about LLMs, which is while the cost of developing an LLM can run into billions, the cost of stealing them is really low. I speak as someone who was involved in setting up a financial company, and one of our competitors phoned us up one day and said, oh, by the way, one of your staff has just turned up in our office offering to sell you. If we give them a job, they'll bring your model with you. You can take a large language model out of a lab on a USB stick. Okay, so the costs of piracy are very, very low. So this is a very, very strange technology in terms of the diffusion of pirated technology. So the cost of build and cost of steal, we've never seen anything like that. My final kind of big significant thing, which I think from a public policy perspective is hugely important, is data corruption. So anyone who's ever been to a wedding where the father of the bride or the father of the groom is giving a speech and they stick the microphone into the speakers and there's that screeching feedback, that's a feedback loop. We are training our models on data from the internet and then using those models to generate the internet. And then training our models on the data from the internet and using those models to generate the internet. This is not going to end well. This is really, really, really bad. Okay, this isn't just a kind of, a talk now. This is bad for humanity. Right? This is a really, really serious problem that people aren't talking about. And I do kind of wake up at night worrying about it. Okay, so to finish up, fundamental things apply as time goes by. So if there are bottlenecks and they're not being addressed, then they are rate limiting steps. So we're not going to expect that this is going to be a radical change from all the other technologies that have come before. And it is following the patterns that we're expecting. It's an interesting technology. It's a new technology. There's all sorts of fun bits, but the fairly kind of fundamentals things are there. We're seeing very, very fast adoption in terms of use, but in terms of transformative use, we are seeing a much slower pattern. And this is a human capital issue. This is a learning issue. And the fundamental issue is difficult to learn within organizations. The innovation bit, I think, is fantastic. But my big worry for the industry is whether they will be able to capture value in the long term. So I think we could see an interesting bit of industrial disruption in the AI industry over the next couple of years. I'll go back to Mr. Watson. These are my predictions based on very little understanding. Mr. Watson predicted 5 computers based on his understanding. That's the caveat. Lots and lots of uncertainty around this. Thank you very much.
I'm going to come to you questions in the audience in just a second, but maybe before I do, inspired by Paul's comments about rate limiting steps, there is a quote from the UK government's AI advisor, Matt Clifford, that there are no AI-shaped holes in most organisations. And that kind of fundamental lack of value proposition seems like a very early rate limiting step. Do you agree with that statement? And if so, what does that mean for how we approach innovation and diffusion policy? Any panelists that would like to jump in?
I can start. So I think the Anthropic data is super interesting. I mean, what that suggests is that across organizations, AI use is ubiquitous. At a small level, how do I reply to this email? How do I plan a meeting? Those sorts of things. There are lots and lots of holes in organizations that AI is a brilliant fit for. It's the more difficult transformative stuff where it's harder. So I wouldn't agree that there are no AI-shaped gaps. There's lots of them, but being able to transform an organization is the difficult bit.
Natasha, did you want to come in there as well?
Thank you. Yeah, I think, I agree. And I think the point is that it's not so much that you create the AI and then look for the gaps that the AI fits. You say, what are the gaps, what are the needs, and what are the purposes? And we can develop the AI to do that. And that's why I particularly wanted to pick out some examples where AI applications have been developed to meet those particular needs. And I think that's why we are thinking about this approach in terms of intentional, purpose-driven development of AI, so that it meets the needs, rather than you've got a tool and then people will walk around and say, well, how can we adopt this? What gap does it fit? Do we have one? Can we create a gap? that feels a little bit wrong-headed.
Just a very brief comment. I mean, there are definitely AI gaps in my life, AI-shaped gaps, and we've been talking a lot about sort of business applications, but one of the big drivers of new technologies is consumer applications, and the AI gaps in my life are those smart robots that do the laundry for me. And I'm slightly surprised that that hasn't come up very much today.
Flavio, did you want to come in on this? In which case, questions from the audience. Would anybody like to kick us off? Yes, we have one in the centre here.
Hi, good afternoon. My name is Sergio Martorelli. I'm a co-founder of Glass AI. We built AI that deep reads the web and is used by governments and consultancies to research sectors. So one of the key challenges we have in many projects, we do a lot of research for the UK government, EU Commission, Australian government on AI adoption, also with the OECD sometimes. And one of the key challenges we always find is the lack of a common definition of what AI adoption means. Last week, 2 weeks ago, the Stanford University AI Index was talking about 74% of US businesses adopting generative AI. To me, that sounds completely crazy. Doesn't make any sense. So I was wondering, a question for the panel, whether there's a common definition, whether this is an issue, because if we want to inform public policy, if we want to measure the adoption of AI, probably having a definition is the first step, just like having a definition of artificial general intelligence. Everyone has a different opinion. That's my first question. And a second quick question, I promise, for you, Paul. Fantastic talk. I loved it. But you made a point that the UK is performing poorly. And I wasn't sure if you were referring to AI adoption or AI development or both. And the reason I'm saying this is because we research the AI sector ecosystems across countries. And the UK, in terms of number of companies developing core AI products, is actually the third country after the US and China, not in academic papers or patents or big tech AI companies, but in terms of number of AI companies. So I would love to hear from you what you meant by the UK doing poorly in terms of AI. Thank you.
Well, quickly. Okay. So by the way, I happy customer, great company. Very, very impressive company. So should there be definitions? Yes. I mean, there's a really, really serious issue. You know, I have people, we monitor AI use in my organization, and we have people who, you know, take the minutes from a meeting and turn it into a country and western song. Great. You know, they use AI, it's fantastic, everyone's happy, they have a cup of coffee. But that's a very, very different thing from GSK transforming the entire process. And to say that this is AI adoption, it's chalk and cheese. They're very, very different. So obviously, yes, we do need to have some real work on what do we mean by AI adoption. And a lot of the interesting academic work is using kind of capability models to show how you grow and you build and you do more and more things. But that whole area of research is still very, very messy. On the UK performance in AI, it was a science policy issue. So specifically about science, there are, you know, some fantastic firms, world-leading firms in the UK doing brilliant stuff on AI. DeepMind is a fantastic example, but there's also a lot of the financial sector doing great stuff, lots of small firms doing brilliant work, as you say. So it was very much around the performance of the UK across a variety of different performance metrics we use to measure scientific outcomes. So we are a long way behind in that kind of cutting edge kind of innovation space compared to the US, but we are an innovative, open, sophisticated global economy that takes technology from wherever we can find it and applies it in an intelligent way. And UK firms are good at that. So there's an interesting kind of thing there. Does that answer your question? But great company, by the way. I don't get paid by it.
So I quite often think about the parallels between AI and electricity, which is one of the kind of canonical examples of innovation and diffusion and why it took so long. And there's been a fashion for trying to measure the digital economy, which at one point is going to sound like, let's measure the electricity economy. So on the one hand, I can see the merit in having a definition of what AI is, but on the other hand, the interesting questions are going to be about what it's used for. And it's those sorts of, I guess it's value capture questions that are more interesting to me. So I suppose we need a definition, but I'm not sure I think it's the most interesting question.
Yes, I'm gonna take a little bit to take on that. And for sure, I mean, it's a challenging concept to measure. And what we have been doing over the years at the OECD is try and look at different ways to proxy different facets of AI adoption. I was mentioning the AI development, the patenting, the demand for human capital, the mentioning in websites, so the extent to which companies may have more AI at the core of the business, or what comes from the statistical offices that have the advantage of being very, very representative, but having a more limited amount of information of the uptake at the company level. What I think is relevant also for the returns, for the value capturing side, is to distinguish between the development side and the extent to which AI is more deployed or used, both more off the shelf. And we see relevant differences in terms of productivity returns already, as well as what is relevant is probably distinguishing between the type of technology, the type of AI we are talking about, whether it's more the machine learning, the predictive analytics, where you need lots of complements and data, and that is maybe more embedded into capital, into machines, rather than the generative AI that is maybe more easy to use, but the complements are different. It's more the human capital, the critical thinking that may help, rather than just using the technology, leveraging potential. Another challenge is at which level adoption takes place. Is it at the company level? Is it at the worker level? Is the adoption at the company level a meaningful adoption that is not just a worker using ChatGPT to summarize email, but to integrate the use of the technology in the business model? These are challenges that I guess will remain, but hopefully analytical work, leveraging what is available may help us understanding the way forward.
A question over here and then a question over here.
Thank you so much. Oh, lovely. I have two questions. One, I will frame as a biblical question about rich will get richer and poor will get poorer. So it seems like all example of AI innovation is that we and the government try to support already successful examples. So do we believe that it will be diffused on the left behind areas, etc.? or we should think more ambition to support already or develop from the start in the areas that less successful? And the second question directly to diffusion. So if we will think about AI as a disruptive technology that in the first type of technology challenge cognition, because previous example with electricity, etc., it's about manual manufacturing work, but LLMs can think of. So if you're thinking about cognition, A, can we use the historical examples? Because we don't have these examples, unfortunately. And B, thinking about cognition, it's challenge institutional memory in all organizations because they transformation approach built on manufacture, manual work, but not on cognition. So what we should do with this, or we do not believe in AI as challenge cognition, we fine, just ignore it. Thank you.
Natasha.
Yeah, just to take your first question, I mean, this is where policy comes in, right? Is to promote adoption in areas where there's greatest benefit. And I think to link the two different areas that we're working on at the Academy in terms of our policy, we're looking at questions around AI and enabling use of AI, but also looking at questions around complex health conditions. So a particular challenge that we've been looking at is, particularly working with Chris Whitty, is the issue of people with multiple conditions, older people, often people who are living in coastal communities, long way from hospitals, working with lots of different interfaces, having many different appointments on different apps that are on different bases. There's a great opportunity there to use digital technology and AI for remote medicine, for better kind of streamlining of appointments, letting people come into the hospital once for multiple things. And that's where, there's a government intervention to develop the AI for that particular use case, I think is really important. And again, that goes to my point about sort of practical AI and taking an engineering use case, it's a health use case, but there's an engineering solution using AI, and we need to make sure that that is invested in it, because it's not going to happen naturally, I don't think, but it's a clear need.
Maybe building on that, Diane, coming back to your point earlier as well, as there is a demand here for different types of consumer goods. There's also this vast social demand for solutions to these complex challenges. So what's broken in our innovation economy that we're not seeing AI-enabled solutions to those needs?
I think it came up in one of the previous sessions. It's about the link between the people developing the AI models and the market signals being broken. And, I go to Stanford twice a year. There's fantastic stuff going on. Somebody has invented a system of sensors in an old person's flat that will tell you if they've not opened the fridge and eaten or they've fallen over. And if you ask who's going to pay for it, there's silence because they haven't really thought about what the market will be. So there's demand signals, I think, are often missing. I was going to talk about the other question, if that's okay. Yeah. And I think there has been a general purpose technology that challenged cognition, and that's the printing press. And unfortunately led to 100 years conflict afterwards in those power struggles between the scribal class that Anil talked about this morning and those newly empowered by the technology. So I'm not sure that's a very encouraging example to look back to, but it might help us think about how to avoid such conflicts this time around. You're nodding there, Paul. Do you want to add to that?
Yeah, I think that's a very, very good example of an interesting impact. I'm not sure it's going to have as big an impact as the printing press, but it's going to be interesting. To your point about the kind of inequality bit, there's good evidence on the impact of new technologies and how they affect inequality. Process innovations initially tend to increase inequality, so they make rich people richer and poor people get displaced and kind of lose their jobs. But in the longer term, there's a kind of a social change and they kind of catch up. Product innovations generally improve kind of quality all round, particularly if prices are pushed down. I think there's a big issue around monopoly power over data. So, if this is, as I was suggesting, likely to be a very concentrated industry, I think there's some really serious issues there, particularly as there's a lot of interaction with states. So, it could be that, whether you lose your job or not, or quality of life goes up is an irrelevant thing compared to Elon Musk, having control over driverless taxis and having links to taking people and sending them off to God knows where because there's been a glitch in some system. So I think there's a potential very kind of dystopian kind of elements to this that probably is the thing we really should be worrying about.
Flavio.
Okay, I can possibly add a little bit on the inequality angle, but more focusing on the inequalities between firms, which is what we have been more looking at in some of the data. And what we see with respect to what I was presenting is, so it's the largest firms that are adopting, even within sectors, productivity returns tend to be higher among the larger firms. It's more the developers that already capture some returns to AI development, which can be those that are already best placed in terms of the complements or the human capital or the extent to which they are able to integrate the technologies in their organization. And this may have relevant implications for inequalities between firms that have been increasing over time, and this is well known. And this is linked with inequalities more general to the extent to which productivity inequalities are linked to wage inequality and overall inequality.
A very, very important point. So what's just been highlighted is that the impact of these technologies is concentrated in a small number of firms. James Besson has done some brilliant work looking at those firms and just the investments in software. And what we have is a small group of firms increasing productivity in the market, and it creates this kind of monopoly issue. And it's starting, we think, to have an impact on kind of industrial dynamics. So the kind of decline in small firms and the ability of small firms to grow into big firms. Turgid markets emerging. I mean, there's quite a kind of an issue here. There's a new phenomenon around software intensive firms across all sectors, not just software sectors. So software using firms that invest in software, that I think is a worry. I think is from a public policy perspective, it is a kind of, creating these monopoly positions that is a concern. So, one of the worries about James's work, there's lots of worries about kind of the impact of the phenomenon he's studying. But one of the worries is the very, very close correlation between the firms that are doing the investments in software that he highlights are driving these effects and uptake of AI.
Bill.
So back to DeepMind. DeepMind did something which seems to have been quite unusual and extraordinarily effective when it developed AlphaFold. So not just relying on the ability to identify patterns in enormous quantities of data, it actually integrated what we know about the structure of proteins from crystallography. It went to nature and actually learned something that had not been translated by human beings into a body of text that could then be searched for probabilistic prediction of what was likely to be the next thing. So my question really, and this is an engineering question to an extent, to what extent is generative AI self-limiting, particularly as you get into the generating data, which in turn it analyzes and the models collapse? Is self-limiting to the extent that it doesn't take seriously the fact that we know a hell of a lot about the real world from actually doing real science, and that is an available resource for genuine intelligence rather than artificial intelligence.
Yeah, I think it's a very, very, very interesting question. So as kind of as a bit of background, the AlphaFold drew on a publicly available, very rigorous, curated data set, which was the SwissProt data set of protein structures. And this is something that medicinal chemists and people working in academia and the pharmaceutical industry have been drawing on for many, many years. And it did some really, really cool science around it. So, they deserve that Nobel Prize. But there is an issue about the extent to which we are, as society, curating that sort of quality data still. And the threat that AI technologies pose to that, both as the kind of the generation of artificial data and just is this going to displace all those public investments that we've had to done for many, many years? And SwissProt was a really, really difficult thing from a science policy perspective because the Swiss taxpayer was paying for it. And the Swiss taxpayers were kind of being very Swiss taxpayer-y and saying, well, we aren't the only nation that benefits from this. Should we not give it out for free? Should we kind of, get people to pay for it? And all those kind of public policy issues around the governance of knowledge, and which extend out to pretty much every bit of what academics do in terms of research, are really, really important. I do not think we are close to having any good understanding of it. But I will hand over to someone who's chair of ESRC's council, who's done a lot of work on this. So maybe you've got an answer.
So I think there is a real question about the extent to which we continue investing in data and in things that can be coded as data. And there's a risk that we're going to stop doing it, as Paul is just saying. There's another long-term question as well. So a lot of the case studies that have looked at how you can use generative AI to in an organization or a company find that it augments the more skilled workers. They do much better, and it can replace tasks being done by less skilled or more junior workers. But then these organizations, the ones that I've spoken to, worry about where do the next lot of senior workers come from, because there is non-codified experience that matters for creating things of value as well. So it's both a question about we need to invest in the quality data, but also we need to think about long-term effects as well.
Just adding on, maybe taking a broader perspective on the impact of generative AI on innovation more generally, I just wanted to mention that if we take a general purpose technology perspective, the extent to which generative AI may be able to spawn innovation in other sectors and generate a positive feedback loop, maybe in innovation, maybe one of the channels that is probably yet to be fully measured, but through which the longer term returns to generative AI may materialize to the economy. And as Diane was saying, the case studies, but also the experiments we have been reviewing point to some positive implications with the caveat, or with the fact that the skills of the most skilled worker remain relevant in realizing these returns. And we are doing some initial analysis on this topic at the OECD, more particularly looking at the GPT characteristics of generative AI, of pervasiveness, improvement over time, and innovation spawning. And we see some preliminary evidence that there are some positive feedback loop in innovation that start to be visible when it comes to generative AI patents, although is rather probably early to have a definite answer. But I think this is one of the channels that may be very relevant for the longer run returns to generative AI that in the current macroeconomic estimates tend to be positive, but to some extent milder.
Now we have a question from online, which I think picks up on some of Paul's comments about the security risks associated with AI adoption. So what are the best ways for firms to prevent data leaks and piracy when adopting AI? Are we talking about stronger legal action or tighter controls like compartmentalization?
Okay, that's a very, very difficult question. Okay, I'm guessing here. I don't know the evidence on this. I mean, what we do know from talking to professional service firms in London is that they're very, very concerned about, people coming in and, not being properly through HR processes around confidentiality, sending client data, just sticking stuff into ChatGPT and off it goes. And these are in sectors that are insanely regulated, and 1% of global turnover sort of fines for getting a spelling mistake. So these are very, very significant worries. I'm not sure. My guess, and this I should highlight as a guess, is I'm not sure this is a specifically new issue. So I don't think this is any different from people going in with a USB thing and taking a whole load of data and walking away from a competitor, or leaving stuff on the train, or leaving stuff on the bus. I think this is just a generic thing. So I think it would basically be good data security practices, and we pay people to worry about this stuff. You're an expert on this. You should know this.
I do not know the answer. I will try.
I would only add, what legal restrictions? The Atlantic published a list of all the books that have been sucked into Meta's Llama model. Mine are there. So I think if you ask it for the history of GDP, it'll give you a nice summary of my book and save you buying it.
We have a question in the middle here.
a slightly throwaway comment about whether we should follow the Airbus model and presumably create a European AI structure of some kind. I guess particularly given the problems we keep coming back to around dominance, mainly of US companies. I'm interested in whether does the panel as a whole, including Diana, is that a model worth pursuing? Worked quite well with Airbus.
Diane, are you happy to expand on the Airbus comment to start?
So the thinking is that it's a different sort. It's obviously a way of a public-private partnership, hopefully creating a model that could compete effectively in the market with the ones that are already there. So there is certainly a question about what products would it be able to develop and would they be commercially successful. But it's a market where scale matters. And part of the inspiration is thinking about other markets where there's a different corporate structure or business model that introduce different competition dynamics, and that's broadcasting. And the public service broadcasters, but also the different cultural environments and market structures mean that you get a healthy diversity in those markets compared to the ones that we're talking about now. So that's the broad thinking. There is, Airbus is a successful example. There are plenty of pan-European projects that have gone very pear-shaped, so there are counter-examples as well. And that's the kind of thing that we're trying to work through at the moment.
I mean, Airbus was a very specific issue addressing a very specific market failure, and the kind of the Paul Krugman thing. It's the one thing that he highlighted. Industrial policy did work and should work as it did. I'm not sure with large language models, etc., we're dealing with that kind of natural monopoly. But I do think that the debate that's going on in Brussels and in national capitals around Europe is much more one about national security and whether or not access to technology might be turned off. And that is, and not just in Europe, also in Canada. And that is something where I think the debate is still open and still ongoing. The costs are very, very large, and I think obviously with any spend of that much public money, there's two things. One is massive opportunity costs. Could we use that money to do something better that would solve the problem? And also, do we trust our ability to actually deliver on that? So when you've got that much money involved, you get a kind of a governance issue of major problems. So I think it is a national security rather than a natural monopoly problem, and I think the costs would make it a very political decision that I wouldn't really feel qualified to comment on.
Thank you. Yeah, I mean, I can't say much about the specific model for Airbus other than that it created huge opportunities around the UK. And I think whatever we do need to find ways to enable AI to provide growth for AI for the UK. We have this model of AI growth zones, which primarily that seems to be zones that will enable AI to grow. But I think we need to be thinking about this in terms of enabling growth across the UK via AI. And I think models like Airbus, which did create jobs and opportunities in lots of different regions, are something to look to.
Question.
Enlarging on this question, there is a proposal called Eurostack. There is a proposal called Eurostack that is very ambitious because it proposes to address the entire stack from the hardware on up to the data. And I wondered if you had specific comment, if anybody had seen that. It does raise questions when you get something that's that ambitious. You already have in Mistral a reasonably promising French model that I think, based on my experience, looks pretty good. So where do you draw the line on something like that if the interest is national security, or are you trying to develop a viable business model like Airbus?
So I think that I mean, Mistral is obviously really interesting and good company. I think the question is can it ever match the scale that you need to compete effectively against the incumbents? The Eurostack idea, I don't know a lot about it. It seems much more ambitious than just focusing on the level of the AI models. And so we saw earlier how complicated the supply chain is. So if you're thinking about the whole stacks and not just what we saw, but the model layer and the data layer on top of that, that seems a really a madly ambitious project to me. So I think the Airbus idea is more straightforward, but others might disagree.
Yeah, I don't know details. It does raise a lot of alarm bells for me. I think anything that ambitious, and just given the complexity of the technologies that we're talking about, I mean, Europe has struggled in semiconductor chips. It's been brilliant at the production of the technology that makes other firms do that. I would think there's a lot of alarm bells about project delivery here, whether or not Europe could do that, given the fragmented nature of the political system in Europe, and the, you know, we've seen already on the military side that national priorities seem to be taking a lot of undue influence on processes. So I wouldn't imagine that this wouldn't also suffer from those problems. So it could be a very expensive failure. And if you've got a success already, then maybe the money could be spent better on something else.
And I think we had one final question at the back there.
Hi, I've appreciated the remarks in this session. As I mentioned earlier, I was recently in Silicon Valley, and in the remarks today, I've kind of noticed this difference between the culture of policymaking that we've heard about today, which is very concerned with measurement and neatness and formalizing and process and things of that sort. Whereas if you go to the tech folks in the Bay Area, they're very comfortable with being messy. They're very comfortable with dealing with decentralized work approaches and collaboration between private side and open source and lifting data that's publicly available from wherever and just getting the thing to work. So the question is, how do you square the different cultures we are seeing collide here, where policymaking aims and aspires to be very formal and very measured and very process-oriented and accountable, but technology development itself, especially led by the frontier modelers, is much more messy and less concerned with that?
Bridging bottom up and top down.
It's an interesting question, and I think the thing that came to mind when you were talking is something that's my perspective doesn't quite reflect what you're saying, because I think there's something that's kind of bridges the two, which is the kind of idea of using much more challenge-based policy to enable outcomes. So, for example, it was nice to see with the Manchester AI Prize that the first round's looking at questions around sustainability, around infrastructure, around solving some major problems, which enables people to move quickly and do exciting things, not within a very formalized kind of measured system, but with a clear kind of purpose and aim. So I think there's, I don't know if it's a middle way, but I think there's something that's a little bit different to the two extremes that you gave there, but an interesting thought.
Any final comments from our panel, Diane?
I wonder if one difference is we're much more focused on not having it work at the expense of other people. And I guess the one that comes to mind there is models using copyrighted data, and the debate that's going on at the moment here about, is it more important to protect the copyright of creatives versus getting some fancy model that's actually based elsewhere to work?
Probably a comment on the policy implications that we can draw from our work, that is basically pointing to having the evidence base and then some evidence upon which base these policy implications. fostering human capital, strengthening human capital, critical thinking, the digital capabilities and the infrastructure, and the OECD is at the forefront of the development of this AI principle for trustworthy AI. So many of these are evidence-based policy recommendations that remain relevant also in the next stages of technological change as the technology develop. So I don't know if that helps contextualizing the question, but that's something I can perhaps add.
So I should say I'm pretty skeptical about and critical, I think is probably a better word, of the European and the UK approach. So we have a wonderful ability to regulate stuff that we can't actually produce, and that regulation has very little influence on the technology that is being developed in other parts of the world. So we become a kind of an importer of problems from other places. So I think there's quite a serious problem with the way Europe works here, and I would include the UK within that. And I think there's a lot to learn from the US system. But I do agree very strongly that we shouldn't be uncritical in looking at the good bits and the bad bits of the US model. But there are a lot of good bits from an innovation perspective.
Well, thinking about what we can produce is a nice segue into our final panel on use cases. So please join me in thanking this panel for their contributions this afternoon.